Dear students, very good morning. Today we are going to begin with the problems of total derivatives. That is, we are going to differentiate implicit functions. Our first problem is to prove the formula. What is that formula? Is if u equal to f of x comma y, if u equal to f of x comma y, then we can prove that du by dx equal to dou u by dou x plus dou u by dou y into dy by dx. Since here we are taking x, so we will have dy by dx. Okay, this is what we want to prove. Now we have to prove this. Okay, how to prove this is what we are going to see. So our first formula of total derivative is, we are having du by dt is equal to this formula. I have already explained the formula. So suppose we are having u, and this u is the function of two variables x and y, and okay, u is the function of two variables, and we are having t. What this t is a variable, and this x is a function of t, and y is also a function of t. So u is the function of two variables, whereas x and y are the function of one variables. So here we will have dou u by dou x. Okay, dou u by dou x. Here we will have dou u by dou y. Here we have dx. Since it is function of one variable, we can use ordinary derivative formula, dx by dt. Here we have dy by dt. So here we can use ordinary derivative, whereas if the given function is a function of two variables, means we have to use partial derivative. So du by dt can be written as dou u by dou x, dou u by dou x into dou u by dou x into dx by dt, that is a formula, dx by dt. This is our first formula, dx by dt plus dou u by dou y, okay, dou u by dou y into dy by dy by dt. Okay, so this is our first formula. Now if I substitute t equal to x. Why I take t equal to x? Because in the formula we are having t, whereas in the statement of the given problem we are having x. So I am taking t equal to x. Then this diagram will become u, and u is the function of two variables x and y, okay, x and y, but here we are not having t, So u is function of two variables x and y, whereas this x is already a function of itself and y is also the function of x. So here, since u is function of two variables, we will have dou u by dou x, dou u by dou x. Here dou u by dou y. Here y is a function of x, so dy by dx, dy by dx. So this is one type. Another type is, so we can write here du by dt equal to du by dt, du by dt is equal to actually dou u by dou x. Okay, it is dou u by dou x. Okay, dou u by dou x into dx divided by this t has become x, so dx by dx plus dou u by dou y, dou u by dou y into dy divided by dx. Okay, now this dx and dx will get cancelled. This dx and dx will get cancelled. Okay, this is nothing but d by dx of x itself. So differentiating x with respect to x will give 1. Actually this is not cancelling. Differentiation of x with respect to x is 1. So dx by dx is 1. So we get, also from the diagram, it was confirmed from the diagram, that is du by here we have to take x. We have to take x. You have to take x. Okay, so du by dx equal to du by dx equal to dou u by dou x plus dou u by dou y into dou u by dou y into dy by dx. Okay, see, that is how to reach t from u is what our actual formula tells. First formula tells. In the second formula, this formula tells how to reach x from u. So we get d. Okay, so we get the statement proved. So hence it is proved. Hence the statement du by dx equal to dou u by dou x plus dou u by dou y into dy by dx is now proved. I hope you all understood the problem. Thank you for watching. Thank you all.